Hello everyone, in this video we're going to have a look at behavior 2. If you use Game Creator 1 and behavior 1 before, you might think this is just simply behavior trees for Game Creator 2 like the first one did. However, this isn't the case. Yes, we have behavior trees, but we also have state machines, GOAP and utility AI. And this might seem quite a bit overwhelming and maybe you just don't know where to start. So unlike with Melee 2, where I just showed the examples and told you how awesome the module is, I think it's useful to have a look at what all of this actually is. So let's have a short look at the differences between these video game AI models. First up, we have state machines. Not to be confused with the state machine module for Game Creator 2, which basically is a different way to visualize your triggers, actions, and conditions into a graph type system. This type of state machine that we're talking about right now is purely the AI model, and it was most famously used by games like Half-Life and Oblivion, and it's one of the oldest models for 3D games. That, truth be told, won't always allow you to make the most complex of AIs. It is a cheaper solution, however, in terms of computation, so it might be perfect for example shopkeepers or civilians. So let's have a look at how this works. We have our entry point, then we go to an idle state, and from that idle state we can go to a walk state and go back to idle as well. And we can then from walk go into run, to attack, and to patrol, and all of this is with a bunch of if statements, so basically conditions. Now this works really basic, it's quite simple to control. However, you can have the moment you make this too complex, like for example Half-Life had about 80 different states, which created an immense complexity, and same could be seen in Oblivion. And when it becomes that complex, it's really easy for characters to stay stuck in certain states and not have a way to go back. So it's great for simpler work, but the moment it becomes too complex, I wouldn't recommend using this. So next up we have behavior trees, which definitely increase the complexity of your behavior. And it's been around for a while, but it really kicked off with Halo 2, which was kind of the entry point for these types of AI models in video games. And they're still used till this day in the majority of games really. So we have shooters like The Division, Far Cry, Halo Infinite of course, and many other games all use behavior trees. One of the strengths of behavior trees is that as a designer, you are in full control of what happens. And there's only a really small margin for error. So let's have a look at how this works. So we have our entry point, just like before. And then we go to different conditions. So we have, can we see the player? We don't see the player, and these have priorities. So seeing the player will be the higher priority. If we don't see the player, that's the lower priority. Then if we don't see the player, we're going to patrol until we actually see the player, and then the first part, so the left side, will kick in as that is a higher priority, and then we will have separate conditions again. So are we in range of the player or are we not in range of the player? If we're not, we're going to run towards the player until we are in range, and then the left side will kick in and we're going to attack the player. So as you can see, it's a lot harder for this to get stuck into. If some conditions are no longer met, it will automatically switch back to the other part of the tree. Now this is really it's a really good model. You are in full control of it as a designer. It's really popular still for a reason, because it allows you to exactly dictate every inch of the game. Now, one of the downsides of being fully in control of what happens in an AI is that it becomes really predictable. Now, of course, this can get incredibly complex. So when you look at The Division 2, for example, there's some videos about how complex their behavior trees actually are. And to call that predictable might be a bit of a reach. It's incredibly complex. However, yes, it's a lot of work, but you're in full control. Now, if you want this to become less predictable, which can definitely be favorable in some type of games. If you're going for more realism, then there also is GOAP. So goal-oriented action planning was most famously introduced into the industry with Fear, which is still seen as one of the best AI behaviors in any game, or at least any shooter. And it becomes really lifelike, because as a designer, you're not actually fully sure what's going to happen yourself, and you might actually be surprised by how the behavior of the AI enemy goes. So let's have a look at how it works. So first off, we have a state, which is idle. Then we have a goal, which is kill the player. And then we have all of these actions with preconditions and outcomes. So the precondition is, for example, for attack is see the player in range, and then the outcome is kill the player. Now that certainly matches the goal, but in the beginning we don't see the player yet. And this is where GOAP will try to combine all of these actions with preconditions and outcomes in the best way possible to reach that goal. And as you might guess, if you add a lot of actions, this can actually become quite interesting, because the AI will choose itself which is the most efficient or best way to reach a goal. And this can create really complex behaviors where you don't really know yourself what the AI is going to do. It can make it really lifelike, it can make it really interesting, and it can be literally the best, like we can see with Fear. But there's a reason not everyone does this, because as complex as it can be, it also is a little bit heavier on computing. To be fair, with Game Creator 2, that is a bit less the case. It's actually incredibly performant, but it's incredibly complex to make a good AI that functions like this. So even though in theory you have the most potential, not being as much in control can sometimes result into a type of behavior you preferably don't want to have in your game. And it definitely doesn't fit everything, and to be honest, it just requires a lot more work to get it right. But if you have the time and you want to create more unpredictable lifelike AI, definitely go with GOAP. Just keep in mind, you might be investing a lot of time and not get the outcome you want, because again, you're less in control of what happens. That is the downside of being less predictable. Now, lastly, we also have utility AI, and this is a different type of model compared to everything else. It won't fit every game, and at the same time it is perfect for certain type of games where the other models actually really fall short in comparison. So utility AI is basically based around needs, and this was first visibly introduced in The Sims, where a character has a bunch of needs like sleep and eat, and depending on which need is bigger, it will go and do that. Now obviously this is great for games like The Sims, but also really cool for games with civilian AI that is just walking around in a village, for example. It will have a bunch of needs, and it will then plan its day accordingly to whatever need is bigger. If you intervene, and for example hunger was the highest, second highest need, you give it some food, then that need is satiated, and he will actually go ahead and go to the next need that is highest after that. So let's have a quick look at how this works. So we have our stats, so we have rest, hunger, social, fitness, and thirst, and all of these stats will be at a certain percentage, for example. Then we're going to introduce a bunch of actions it can perform to satiate these, and depending on which need is the highest, it will go and fulfill this. So like I said, for example, if hunger is the highest and the AI is on its way to buy food, you intervene, you give him food, he will eat, and then straight away he will go to the next need that is highest. And this is actually a quite simple way to introduce dynamic AI in a village, for example, and can be incredibly cool without being too difficult to make or too heavy in terms of computation. So definitely a really cool alternative. Didn't expect to see that in here, so really awesome. that behavior 2 is not just going to focus on the more popular models, but that even something like this is in there, because I think a lot of people actually like this for a lot of their NPCs. So now that we're in Unity itself, we'll see all of these, and let's actually install everything. So I want all of the examples, and we're going to have a look at literally all of these different types of models. And what I like as well is definitely what was added here. So we have beginner, we have intermediate, we have advanced, and we have advanced. So maybe my statement about it not being the most difficult way to do it was slightly incorrect in how it works in Game Creator, but I definitely think this is one you shouldn't ignore, even if you think I'm not going to create The Sims. If you are going to create, especially for an open world game where you have random NPCs, definitely have a look at this, because it's incredibly cool. If you are creating a linear game, the chance of you using this is most likely going to be quite slim. It's not really the the most go-to model for a linear type of game, which is where most likely you'll have either behavior or GOAP. The chance of you using state machine, actually, I mean, I personally wouldn't recommend it, even if you are just a beginner and you're new at this. I've done so many videos on behavior trees for Game Creator 1, and in terms of functionality, it works pretty much the same. There's so much stuff around behavior trees. So if you are a beginner, I would still most likely skip state machines unless it's for certain types of behavior, where you just want something really simple. But I wouldn't even do it for patrolling guards. I would literally do this for, shopkeepers, things like that, where you do need a type of AI interaction, but it's not as simple. It's not a typical civilian, for example, like with utility that just goes around his day. No, he still needs to be in some places because he serves a function, but he doesn't need the most complex of AIs. Now, when it comes to behavior or GOAP, this is definitely a more of a pick and choose. Again, behavior really predictable, which makes it easier in a way because it's fully in your control. But if you want it to be more unique and more lifelike, then try GOAP. But I wouldn't recommend doing this before you understand how behavior works, in my opinion, because at least you need to understand how everything would work in a certain logic. If you master that, then you can try this to get out of that logic, basically. So sorry for talking this much. Let's have a quick look. So when we go to our installs, so we have our examples. So let's have a look. And these examples are incredibly cool, by the way. It's really quite interesting how all of these examples work. So when we have a look right here, so we can enable our characters, and they will all serve a certain function. Now, if we have a look at our characters, the way this works, so we have this component called processor, and it will have this action plan, and let's drag it out. And yeah, in terms of design, it will look a bit similar to how behavior 1 works. It looks, but yeah, functionality is quite different. So like I said before, so we have our our conditions, our outcomes, and based on this, it will pick whatever is the best suited at that point. And as you can see, this will actually look really dynamic. You can play this several times, and the behavior won't be they won't all be following the exact same model. Now, with behavior trees, that will most likely be a lot more the case, and they're all going around their day. So it's actually really cool. Definitely have a look, play around with it. Well, don't play around that much. Like, definitely play it several times, and you'll see that the outcome is done. Now, as you can see here, they're done. So, you know, they've reached their goals. There's nothing to do anymore, and they'll just stay idle. Now, if you play the scene several times, you will see different types of behaviors in a way of the AI not doing the same thing every single time. So really good example, really quite unique example actually. When it comes to behavior, a lot of these will be quite similar to what you're used to. This is actually quite similar to one of the examples in behavior 1, where you have a a player, and then he's going to look for you, and if he sees you, then he's going to well, he saw you, and that's pretty much it. As you can see now, straight away he didn't go patrolling because the condition was met. So if we have a look at what you call the seeker in this sense, yes, this will be incredibly similar to how it works in Game Creator 1. Really glad subtrees are added straight away. I started doing this way too late with Behavior 1, but subtrees, subgraphs definitely allow you to fasten your process, because a lot of the characters will have similar type of behavior. If, for example, you have a village, you will have a guard and you will have a normal civilian walking around. Their walking around behavior will be the same, so you can reuse that by simply reusing that graph. And then other parts of the graph will be different. So it's just a time saver. So I'm glad it's in there, kind of to try and force you to have a proper look at how this works. But yeah, behavior trees are really simple. It's this is the sequence. He's going to count, then he's going to select, does he see the player, yes or no, and then he's going to say he saw him, otherwise he's going to walk around. So really, really simple. Have a look at it. I've covered it so many times how behavior trees work, so I'm not going to spend too much time on it. Then we have state machines. This is actually quite a famous example of how state machines are often visualized. So let's have a look at the graph itself. So as you can see, it's a lot more basic in the way it works. It is the definition of predictable pretty much, but to the point where it definitely just won't allow for a lot of complexity. So yeah, keep that in mind when you use this. I wouldn't even do it for guards in games, because you'll have combat, you'll have all of that, so I wouldn't even use it for that. Literally, just because there are better models, I would keep this for definitely some of the more basic things. Then when it comes to utility AI, definitely one of the cooler ones. So let's have a look at the graph before we even dive into playing. So these are the needs: go home, drink, dance, and based on the needs, it's going to perform these. Now, the reason complexity was seen as a bit advanced when we have a look at the examples is because it's just really different. However, I am still convinced, and I would definitely recommend this for your villagers, because it is a really cool way to still have really dynamic AI. And yeah, especially if you have open world games, if you have open world games, there's so much that can be done with this. It's just incredibly cool. So I'm not sure what's going on here in this example. But yeah, it's a really cool way to create just really cool behavior in your game. So yeah, don't go based on this example for it, because everyone was getting in each other's way. But yeah, there's so much to be done with this. I would definitely recommend this. Really cool stuff. So I know this wasn't the most typical video, but I know how overwhelming it can be when you install this. You were used to either nothing yet or Game Creator 1, and you're like, okay, so what do I do here? So I really wanted to try to spend a bit of time into explaining what everything is first. Yes, we had a look at the examples, but that still doesn't tell you that much. So I hope my explanation helped a bit. When it comes to our own game you know, in the Game Creator 2 series that we're doing right now, the Create a Game series, we're actually going to be using several of these models. So I'll be focusing on this one, utility AI, state machines, and behavior trees. Now GOAP, I might get into at a certain point. To be honest, it's just it's a lot more difficult. I know you can get amazing outcomes. It's just a lot more difficult, and I feel like I need to invest more time into it myself. But we'll be using all of the other trees in the series. And I definitely am going to spend time on GOAP in videos as well. But that will definitely be a bit further down the line, as you know, it requires a lot more attention and dedication. So thanks for watching everyone, and I'll see you in the next one.